Hi guys, I hope you're good since last video. We have seen that Google has released his zero-shot video model. Here we are going to focus into the Meta AI new Omnilingual model, also using zero-shot. Let's get started. ASR, automatic speech recognition, so Omnilingual ASR, an open source multilingual speech recognition model. After here there is a little introduction, some different claims around what this model is able to do, the methodology, and we are going to go through the different sections that might be interesting for us to read, and also around what we can understand of the paper. So Omnilingual ASR, the first large-scale ASR system designed for extensibility. More specifically, Omnilingual ASR enables communities to introduce unserved languages with only a handful of their own data sample. That's what is special about this model. Self-supervised pre-training on 7 billion parameters to learn robust speech representation, and introduces an encoder-decoder architecture designed for zero-shot generation. Okay, so over 500 never before served by any ASR system languages. So out of those 1,600 languages, there are 500 that have never been served by any ASR systems. A family of models ranging from compact 300 million variants to 7 billion parameter models. See in the paper they talk about 3 different ones. Written by all those people. And they forgot Creditizens, but it's fine. We forgive them. Let's open the PDF. It's a huge one, there's 53 pages. We are not going to be going through the 53 pages. We're just going to go through some different comparisons and read a bit just to get an understanding of it. So just keep reading the paper. Okay, so the table of content here, you can use that as a guide to go into the more what interests you. So Omnilingual ASR models, zero-shot speech recognition from unseen languages, model training and evaluation, Omnilingual ASR versus different other systems, USM, MMS, Whisper, accuracy of zero-shot models on unseen languages. Okay. Comparison with Omni ASR. Let's go to the page 20. Let me find the right section to start with. Yes, we can go with this one probably. Omnilingual ASR versus Whisper. Whisper is a multilingual speech model. So let's start with this. Omnilingual ASR versus Whisper. Trained on approximately 5 million hours of weekly labeled web audio and supports a range of speech processing tasks, including ASR in 99 languages. Its architecture is a transformer-based sequence-to-sequence model. And after here, they just show us on the left side the models. There's a dev sample and the test. Like for the training, when you have your test sample, train sample. Okay, so thanks to its strong performance an easily accessible API, Whisper has become one of the most widely adopted speech model in research and the developer communities. And after here, we can see they compare ASR, their own model, with Whisper, large V3. And they're also using the MMS Lab, Fleur, MLS, and Common Voices too. So those are languages samples. Okay, comparison against Whisper v3, including its large 1.5 billion parameters, medium 769 million parameters, and the small, which is 244 million variants. So there are three different models. For each benchmark, they report the average CR across languages on both dev and test splits. The comparison only consider languages that Whisper covers in each benchmark, and the number that follows the dataset name indicates the number of languages considered. So the two rightmost columns show the win rate of the model against Whisper large v3 on the Fleur test set, which is 81 and 81. So there's 81 languages, while the other one has 34 languages. So considering the top 50 most spoken languages in the world that are covered by Fleur 34. Okay, so 34 and 81 is not the number of languages. The win rate here, the 7 billion parameters LLM ASR is the one performing the best. So automatic speech recognition, they build on top of a Wave 2 VEC 2.0 speech encoder to construct two variants of ASR models. The first variant is a connectionist temporal classification (CTC) model, a framework designed to handle input and output sequences of varying lengths without requiring explicit alignments. So CTC. CTC has become a foundational method in speech recognition and other temporal sequence tasks by enabling model to learn alignment implicitly. So it captures the temporal dependencies and has driven state-of-the-art performance in multiple applications. The CTC model here comprises a single linear layer and so on. And after the transformer decoder have achieved the state-of-the-art performance in natural language processes tasks by effectively modeling complex sequential dependencies in ASR, taking a transformer decoder on top of a speech encoder enables the system to leverage risk acoustic representations while capturing a long-range context. So here they're explaining more what are the advantages of using that. And the modalities. As a result, it improves transcription accuracy, robustness in diverse speech recognition. And after here, you have this formula, which is obvious. Okay, so I can't explain you those formulas. Zero-shot speech recognition. Nice formula here again. The supervised, and after here, they'll be explaining the DSR model. Described above supports over 1,600 languages using label data. However, there remain languages for which no label data are available and which therefore cannot be supported by this purely supervised approach. To address this gap, they extend the LLM ASR model with a zero-shot capability that allows it to perform ASR in any languages or domain, including those unseen during training. So it's magic. The key idea is to shift from a single sample supervision to context-based training, a training time, instead of providing the model with only one speech-text pair. They are represent here n+1, so they're giving samples at least from the same language. The first 10 pairs serves as a context example and are prepended to the transformer decoder prompt. So the final pair is the largest sample whose transcription the model is trained to predict in the standard next token prediction framework. So this design teaches the model to condition a few sample of speech pairs from a language before producing a transcription for a new utterance in the same language. So because the training corpus covers a large number of languages, it is hypothesized that the behavior generalizes to languages absent from a training data. As a result, the model acquires a zero-shot ASR capabilities, effectively enabling communities to extend recognition to their own languages with only a handful of pairs examples. The overall architecture of the zero-shot model is illustrated in a figure. Maybe it will be easier to see it. Just to go into the figure here, auto, regressive, transformer, decoder, and they're using the wave 2 encoder, text embedding, and after for the audio encoder, text embeddings. Okay, so context audio, context text every single time. Here they simplified it. Okay, target audio waveform, target transcription. So audio, text, giving a sample, from that sample trying to do the zero shot. 1,600 plus languages evaluations. So in the previous section they did the comparison, showing that the state-of-the-art performance across multilingual benchmark. Now they turn a broader analysis of omnilingual ASR performance on the full set of 1,600 languages it supports, including the 500 languages that have never been covered. So evaluating model at this scale requires a structured approach. As such, they have adopted two complementary protocols, dividing languages into high, mid, low resource categories based on the amount of labeled training data available, and sorting languages over 14 major grouping following the principle outlined below. So we're going to see the grouping, and we're going to see also, here we have the table evaluation based on the first way, using the high, mid, and low grouping. Resource categories. So this is a labeling system using two different models, 7B LLM and the 7B CTC. CTC, which stands for Connectionist Temporal Classification. Okay. And here there will be labeling those like that, and that's the second way, which is the grouping. Okay, average CSR across languages on the 14 language grouping using the 7B LLM model without LM Fusion. They only consider languages that can be classified into one of those 14 groups and drop the rest of the languages that the model the model supports. The number of languages denotes the number of languages belonging to that particular grouping covered in the evaluation set. So they basically create those grouping, they know those, they have statistics around those, and they drop all of the rest. So labeling and grouping, that's all what we need to keep in that. Zero-shot accuracy on never seen languages. So they concluded experiment to evaluate the generalization of the zero-shot ASR model described on unseen languages. To that end, they included a set of 32 languages from the training set, which will be used for evaluation, the set of evaluation languages was chosen at random, but in a manner that asserts that half of the languages are high source languages that are represented in more than one evaluation set, and the other half are low resource languages that may only appear in a single evaluation set. Since some evaluation sets contain only a small number of evaluation languages, it does not make sense to report accuracy by evaluation set in this setting. Instead, for each evaluation language, they will compute overall CER across all evaluation sets and average this number across languages. Okay, so the context example were chosen randomly for each iterance from the same dataset and in a consistent manner across models. So the zero-shot model are compared to CTC and the LLM ASR baselines, both trained including the same set of languages, which are then used for evaluation to find an optimal setting for generalizing to unseen languages. They experimented with a number of variants of zero-shot models. The candidates vary by the number of context examples used, the seed used to analyze the speech encoder, and whether the speech encoder was frozen during the training or not. After there is a table for that, they are just going to, here they're just describing what the table is concluding to. So, however, when augmented with conditioning and context sample, LLM ASR model outperforms the CTC model and reduces the overall CER on unseen languages from 26.32% to 14.4% using a context size of 10. The largest context size that they experimented with. Among zero-shot models, they found that seeding from CTC reduces the generalization ability to unseen languages. So they also observed that tuning the speech encoder was crucial for demonstrating the zero-shot ability in a manner superior to baseline models. Okay, so the observation is that zero-shot models somewhat degrade accuracy on some datasets of seen languages compared to their non-zero-shot counterparts. Okay, so however, they release separate models for stronger support in languages appearing in the dataset, the training set, making the metrics less important for zero-shot models. So two exceptions are the FLIR 102 and the CV22 datasets. Okay, so for which zero-shot models outperform the baseline model. So that zero-shot model somewhat degrade accuracy on some datasets, and the two exceptions are FLIR 102 and CV22. So here there's no degradation. The reason for this is a relatively high number of iterances in those datasets where the script is being misrecognized by non-zero-shot models, thus vastly increasing the CER. As zero-shot models are provided with a number of context speech and transcription pairs from the language, they significantly reduce script and language confusion errors. Okay, so after maybe we're going to see those sentences. So here they show some references. It's in German. Let's see if you have in English. So here is the table, generalization to unseen languages of the zero-shot models. So unseen refers to the language average CER across all evaluation set for unseen languages, and the rest of the evaluation set specified refer to the portion of those set which languages are seen during training. So here we have the wave 2 and here we have the CTCs. So the context, as I said, is 10, which is the maximum. Those are the scores of unseen. This one is the lowest. This sample of 10. And after here we can see the different data sets. Okay, and we have the different scores. So unseen refers to the language. Okay, let's just go here. That's the English one. Reference text, random, so result for the difference method of context. So here is an example of the transcribed text with different section methods. English is included in the training for the model. Some spelling can be potentially corrected by just changing the context example provided in inference time. So you can see here there is a slight change. You can see the letters. Just observe the words. Encourages. Okay. So you know how LLM works. They just try to predict the next word. So here it's going to be also having some variations of each word, which are not very accurate to what the word is, but maybe overall the sentence is understood. So in their conclusion, Omnilingual ASR illustrates how scaling methods, when combined with deliberate data collection and new architectural innovation, can reshape the trajectory of multilingual ASR. The project not only extends the coverage to more than 1,600 languages, with over 500 represented for the first time to the ASR system, but also reframes how coverage itself is conceived, in contrast to prominent existing systems, where unsupported languages could only be added through expert-driven fine-tuning. Omnilingual ASR demonstrated that recognition can be extended to the entirely new language with just a few in-context samples. So that's what they say in this paper. But after I'm going to give you my opinion, I'm going to try to resume this using a diagram of what I've understood of it. And after I'm going to use a second diagram of what I really think is behind this. The coexistence of massive high accuracy models with lightweight 300 million parameters variance also alters the economics of deployment, making it feasible to adapt ASR both to high compute, cloud infrastructure, and so on. So using the small models for sure is going to be easier and better. This feasibility broadens not only the range of research questions that can be pursued, but also the context in which ASR can be applied for speech recognition, translation pipeline to community-led archive by open sourcing models, training pipeline, okay. For languages, communities, the impact in both promising and contingent. Already, Omnilingual ASR is being deployed in practice. Health practitioners in Nigeria are using the system to facilitate Hausa transcriptions in community clinics with the intention of improving documentation and patient care. In oral cultures, it could help make endangered archives more searchable in education, and so on and so on and so on. Yet, these same capabilities can also be repurposed in ways that conflict with community priorities, from surveillance to unwanted moderation. Distinction underscores the need, and so on. Importantly, our community partner reminds us the need of large technology companies not only to draw open large data, but to reinvest. Okay, here, after I feel like they just putting a lot of contingency words around their research, to say just that they have respected the data and so on. Okay, the language data, but also to reinvest in its creation and the stewardship. Omnilingual ASR was designed in the spirit not as an act of charity, but as part of a healthy, respectful, and mutually beneficial ecosystem in which communities are compensated and so on. Okay, ongoing discussions about consent and compensation in AI training data. You see here, I feel like they're just making sure that they don't get sued or called by any commission. They point to long-standing issues of powers participations on equity in how language resources are built and shared, or approach compensating native speakers and working through local partnership was one attempt to respond to these challenges. Still, compensation should not be seen as a panacea. Some communities may prefer voluntary crowdsourced participation, while others may feel financially pressured in contributing data. Okay. So here they're talking about the different ways to compensate or not compensate, get the data, sensibility of communities, some reflections around that, different trajectories, several border lessons emerge. First, the long-tail language should not be treated as a final frontier to be solved once and for all, but a dynamic, evolving space of collaboration in which linguistic, technical, and social knowledge interact. So after here, they talk about the ideology behind it. The third large-scale ASR is inseparable from the politic and data, how it is gathered, who is compensated, who retain influence over its use. Okay, so future directions include combining omnilingual ASR with large language models to support conversational agents in under-resourced languages, embeddings, community. At the same time, sustaining open multilingual resources at this scale will require policymakers, funders, and interdisciplinary researchers to confront how to share responsibility for building and maintaining them in ways to prioritize long-term community needs. Okay, so we arrived to the end of this paper review, just seeing what are the systems used, which LLMs they're using, what are those sizes, which kind of groupings they're using, which kind of labeling they're using. Please like and subscribe during the break. We need your support. So my opinion, let's go through two different diagrams that I'm going to draw here. One going through what the paper says, what we've seen now, what I understand of it. And after I'm going to do another one, but what I believe what is my opinion actually. So what I got from this, there is public datasets, community audio. So I'm not going to fast forward this part, I'm just going to chill and see me building this diagram. And after I'll be commenting on this, and I'm going to do another diagram and commenting on the other diagram. Okay? So we have the public dataset, the community audio, as we've seen. There's also some text. There's some transcription done. SSL, self-supervised model. I'm calling it Magic ASR. So this is the plus 1,600 languages. So in those languages, there are 500 that are never unseen and never been adopted by any ASR systems. After here, raw audio waveform. Okay, very simple, not gonna overcomplicate. So from those public dataset community audios, we have raw audio waveform, we have speech encoder here that I can put. So here I can put the wave 2 Vec 2.0 style. Let me copy this. Okay, now it's good. So public dataset community audio, we have the raw audio waveform. The SSL self-supervised model, we have the speech encoder, wave 2 Vec 2 style, learn speech representation. And after, under the Magic ASR plus 1,600 languages, we have the multilingual representation. Of 1,600 languages. Try to simplify it at best. After, all the details are in the paper, for sure. Especially if you understand the formulas, the mathematical formulas. After here, I can add LLM-like models. So text encoder, decoder maybe. So that's from the query when we wanna query this knowledge based. So code, script, anything to query that. Conditioned language. After here, optional, maybe given examples for context. Put all inside. We're gonna add one more here. become zero shot enabled. Okay, so it is given some examples. From those examples, the model will be able to guess. Next, tokens for the unknown languages becomes zero-shot enabled output text transcription. Doesn't need to be 100% accurate for this. It's just big steps. Here we go. So let's comment a bit here. So here are my comments. I don't see what is magic, to tell you the truth. Lot of words to cover themselves. Community, the way they reward people or not reward people, depending on how people feel about being rewarded or the data used and so on. So especially in the conclusion. And I don't know, are you convinced by this paper after having read it? I don't know. Okay, so this was the first diagram. Very easy, simple, and a quick comment about that. I don't really see what's magic around that. And do I really believe that's what makes it being able to do zero shot on unseen languages? Not sure, and that's why I'm going to do a second one. So here is the second one, titled What Probably Really Happened. So that's an opinion. We are free to give our own opinion. Let's give our opinion about this. Let me get a square from here and do the second diagram. So, massive private user speech across the world, or okay, that's Meta AI. That's Instagram, all the chats. That's WhatsApp, all the text and audio chats. That's Messenger. Okay, we can't be naive in that and ignore this side of the company and the data that it holds already. So massive private user speech across the world, immense multilingual acoustic prior. Okay, so you get people from all over the world speaking different languages using that. Especially that now people don't want to type, they want to just send a vocal text, and that's how they communicate. And from that, you're able to gather more information about different languages, unseen languages to you, unseen before, because the way the user is using the application has changed over the time. And AI is also collecting those conversations to train itself. So massive private user speech across the world. And after here, fine-tuning, few shots. So from that, you got the data to be able to do your training. Fine-tuning, few shots, trick, for rare languages. It can't be magic. The LLM won't be able to predict the next token just with the process that is explained in the paper. I don't believe so. So I believe this company has a lot of data and is able to use the data at its own advantage in order to train an amazing model. That, yes, I can believe that. Here, let's make it clear. Meta user based. Okay, you have different applications for that, and they're the top applications in the world used to communicate, to share. Okay, we have Facebook, we have Instagram, we have WhatsApp, Messenger, people are using voice. Plus, also the way they're using the platforms in order to know, call it all browsers, spywares. The fact that if you connect into Facebook at home, if there's some other people also connecting to it, they're able to know how many people using the same connection are connected to Facebook, so they get more details about community like that, about a groupment of people. So checking all those tabs also. Okay, and all the people connecting to internet at home. So there's a lot of data just with that. So they're not the only company working like that. Microsoft also is getting Windows being more and more telemetric, more and more sending data, including the AI in every single applications in order to collect more data from you also. That's why I suggest you to use Linux. So after that, I go into another square, SSL++. Self-supervised learning. Model hears every phoneme and accent. Model generalizes across languages. So, in my opinion, this is the more plausible, reason why they're able to do this one shot. If it is proved that they can do it, because I haven't seen anyone using it yet but I've been just checking on those one-shot models recently, because I believe that if you are like me focusing on local LLMs, you need to be able to have a local model. You need to be able to learn about fine-tuning. You need to be able to get those one-shot models, which are very small, run locally easily, and you're able to put them into your systems. So speech is very important. So that's why I've been focused on checking those. So after that, I did add a bit of fine-tuning, plus or few shot streak. And after you get those 1,600 languages, ASR, 0 shots possibilities. And after you can claim that you can do 0 shot from 500 languages that haven't ever been used in ASR systems. But this is more because you have the data backing up that you've been able to train on and get to discover 500 extra languages. Okay. So people are just using the dialects when they're sending a WhatsApp message, vocal one, to talk with their friends and families. So that's how you can get this data. Otherwise, you wouldn't even be able to know about it. Okay, so that's what I believe is more probable. Okay, so here our second comment, which is more correlated to our opinion on that. Just covering themselves up to not get any trouble, let's say, some issues for having used private data to train the model. That's it. That's how I see it. So here I would add also that I prefer the Google way, which is just says that they're training on the data that they got. That's it. That's what is true. They use data houses and they used that data to train the model. That's it. So that's closer to what is the truth, instead of just adding some words, trying to confuse a bit in order to say that, So this is free opinion. I expressed it because I've read the paper, and after I was just trying to... I didn't believe what is written in the paper. That's why I wanted to share it with you. Not being convinced by this paper. And we can't be naive. They have huge amount of data and they're going to use it. Hope that you like this video. Please like and subscribe, and see you next time.